Hello, my name is Michael Buss. My project is titled Discovering Socio-economic Development Profiles of Indigenous Communities Using K-Means Clustering. The community problem I'm examining is that First Nations and Inuit communities have diverse socio-economic conditions, strengths, and planning priorities. A single national average can hide those differences. My research question is, how can K-means clustering be used to identify socio-economic development profiles among First Nations and Inuit communities in Canada using the 2021 Community Wellbeing Index? The objective is to group communities with similar measured characteristics and then interpret these patterns across income, education, housing, labor force, activity, overall community well-being. This can help organize evidence for planning discussions while recognizing that statistical results cannot replace community knowledge or community-defined priorities. So these are data sets and variables. The source is the 2021 Community Wellbeing Dataset. It contains 5,161 community level records and 9 columns. These include the census, subdivision, code and name, population, the 4 component incomes, 4 component indices, the overall CWB score, and community type. I normalized the community type text because the source labels contain trailing spaces. I then filtered the data to 2 categories, First Nations community and Inuit community. This produced 1,141 Indigenous community records consisting of 1,066 First Nation records and 75 Inuit records. The 5 variables required for clustering are income, education, housing, labor force activity, and overall CWB. I excluded the community name, CSD code, and community type because they are identifiers or labels rather than numerical development indicators. I retained population for descriptive analysis, but did not include it in K-means because population size is conceptually different from the well-being indices. I checked the dataset for missing values, duplicate records, duplicate CSD codes, and values outside the expected index range. There were no duplicate CSD codes. The most important cleaning issue was missing data. Of the 1,141 Indigenous records, only 418 had complete observations for all 5 required variables. The other 723 records were missing at least 1 required value. I used complete case analysis because K-means cannot accept missing inputs, and I do not want to invent community-level socioeconomic values through imputation. However, excluding this many records is an important limitation. The 418 analyzed communities may not fully represent every First Nations and Inuit community in the original dataset. Move down to exploratory data analysis and scaling. So before clustering, I performed exploratory data analysis using summary statistics, histograms, box plots, and a correlation heat map. This allowed me to inspect distributions, potential outliers, relationships among the variables. The correlation heat map also demonstrates the overall CWB is strongly related to its 4 component indices. I kept CWB in the primary model because it was explicitly required by the assignment, but I later tested whether removing it changed the results. Next, I standardized all 5 variables using standard scaler. This converts each feature to a mean near 0 and a standard deviation near 1. Scaling is essential because K-means uses Euclidean distance. Without standardization, variables with greater variation could exert more influence on the clusters. So then, selecting the number of clusters. I tested candidate solutions from 2 through 8 clusters. For every value of K, I calculated inertia, the silhouette score, and the sizes of the smallest and largest clusters. Inertia measures how tightly observations are grouped around their cluster centers. It always decreases as more clusters are added. So I use the elbow plot to look for diminishing improvement. The silhouette scores consider both. Where was I? The silhouette score considers both cohesion within a cluster and separation from other clusters. Higher scores indicate clearer separation. The two cluster solutions achieved the highest silhouette score, approximately 0.404. The scores for 3 through 8 clusters were lower, ranging from approximately 0.24 to 0.29. The two cluster model also produced reasonably balanced groups with 190 and 228 communities. I did not select two clusters based on one metric alone. I also compared nearby solutions for interpretability and tested stability across 20 random seeds. For two clusters, the adjusted RAND index was 1.0 for every test, meaning the community assignments were completely stable across those initializations. Where was I? Initial results, stability assessment. Okay, the final model identified two broad socioeconomic profiles. Cluster 1 contained 190. Where was I? Communities and is provisionally named the broad socioeconomic strength. Its average scores are approximately 69.78 for income, 50.40 for education, 82.84 for housing, 75.50 for labor force activity, and 69.64 for overall CWB. Cluster 2 contains 228 communities and is named multiple development priorities. Its corresponding averages are approximately 56.07 for income, 33.36 for education, 62.71 for housing, 65.14 for labor force activity, and 54.35 for overall CWB. The heat map expresses these differences in standardized units. Cluster 1 is above the analyzed sample mean across all 5 indicators, while cluster 2 is below the sample mean across all 5. The largest raw differences between the profiles occur in housing at approximately 20.3. What was I? 20.13 index points and education at approximately 17.04 points. Overall, CWB differs by approximately 15.30 points. These names are descriptive and relative to the analyzed sample. They do not suggest that every community within a cluster has the same circumstances. They should not be treated as rankings of a community value or capability. Let's look at the PCA sensitivity analysis. So where was I? That was the PCA scatter plot. I used principal component analysis only for visualization. The k-means model was fitted using all 5 standardized variables, while PCA projects those 5 dimensions into two dimensions so that the cluster pattern can be displayed on screen. I also repeated the analysis using only the 4 component indices, excluding overall CWB. This addresses the concern that the CWB is derived from related components and might add extra weight to the same underlying pattern. The adjusted RAND index between the main and sensitivity solutions was 0.981. This indicates that the assignments were nearly identical, so the two profile result is simply not an artifact of including overall CWB. Moving on to community impact limitations. And conclusion. So these results reveal a broad socioeconomic gradient within the complete case sample. They may help planners identify groups of communities with similar combinations of measured strengths in areas requiring further investigation. For example, the larger differences in housing and education could guide more focused questions about where additional community-led research, services, or resources may be useful. However, the analysis does not determine what any individual community needs. Important context, including geography, history, cultural strengths, infrastructure, local priorities, and community-defined measures of well-being, is not captured by these 5 variables. The principal limitation is missingness. 723 Indigenous records could not be included. Other limitations are that k-means assumes compact distance-based clusters. The result depends on the selected variables and value of k, and the 221 dataset represents the 2021 dataset represents one period rather than changes over time. In conclusion, k-means successfully identified 2 stable and interpretable socio-economic profiles among the 418 complete First Nations and Inuit community records. The analysis demonstrates how unsupervised learning can organize complex indicators and support evidence-informed discussions. These statistical profiles should complement rather than replace Indigenous data governance, local knowledge, and priorities defined by the communities themselves. Thank you.